Concrete shapes our world, cities, bridges, homes. Yet modern concrete crumbles within decades. Steel rusts, cracks spread, repairs never end. But 2,000 years ago, the Romans built harbors and seawalls that still stand strong. Their secret? A concrete that grows stronger with time, defying centuries of storms. What did the Romans know that we've forgotten? Roman builders were practical geologists, sourcing lime, seawater, and volcanic ash, pozzolana, from the earth. This volcanic ash, especially from the Bay of Naples, was the magic ingredient. They heated limestone to make quicklime, then mixed it with pozzolana and seawater, creating a wet, mortar-like paste. This mixture, packed with rocks or bricks, was often poured directly underwater. Unlike the Greeks, who carved stone, Romans could build massive, complex shapes quickly, even underwater. Their innovation was revolutionary, enabling vast harbors and piers. The choice of materials was deliberate, based on generations of observation. Pozzolana's unique chemistry, when combined with limes and seawater, sparked a transformation. The result? A man-made rock, resilient and long-lasting. Roman concrete was more than a building material. It was engineered for endurance. Their mastery of chemistry set a new standard for the ancient world. Roman concrete's durability amazed scientists for centuries. Unlike modern concrete, it could heal itself, tiny cracks filled with new minerals reinforcing the structure. Seawater triggered a reaction with pozzolana and lime, forming tough crystals called aluminous tobermorite. This process regenerated the concrete, making the sea an ally, not an enemy. Recent research revealed another secret. The Romans used quicklime, creating lime clasts that dissolved when cracks formed, rapidly filling gaps. This dual repair system, quick fixes and slow strengthening, gave Roman concrete its legendary resilience. The material had a built-in immune system. The Romans intuitively engineered a living stone. Their chemistry let concrete grow stronger with time. When Rome fell, so did its secrets. The recipe for their concrete wasn't written down, it was passed from master to apprentice. As trade routes closed and knowledge scattered, the art was lost. The unique volcanic ash became inaccessible, and the skill faded. For centuries, Roman structures stood as unsolved mysteries. Later builders turned to new materials like Portland cement, which was fast and easy to produce. The ancient recipe, slow and patient, was forgotten. Modern concrete prioritized speed over longevity. The Romans' enduring formula vanished into history. Their lost art became a legend. Today our concrete is failing and its production harms the planet. Roman concrete is now a source of inspiration, not just curiosity. Scientists are reverse engineering its secrets, hoping to create more durable, sustainable materials. They're experimenting with volcanic ash and industrial byproducts to mimic Roman chemistry. Imagine seawalls that heal themselves, or buildings that self-repair after earthquakes. The goal isn't to copy the Romans, but to learn from their principles. This marks a shift from brute strength to smart, adaptive materials. Roman ingenuity is echoing in today's labs. We're reimagining construction for resilience and sustainability. The future may be built on ancient wisdom. As we look to the future, we find guidance in the past. Roman concrete reminds us that progress isn't always forward. Sometimes it's rediscovery. Their patient, local approach offers lessons in resilience and sustainability. By blending ancient principles with modern science, we can create materials that last and protect the planet. The next era of construction could unite old wisdom with new technology. Our challenge is to build not just for today, but for centuries. The Romans show us that lasting solutions may already exist in history. Their stones whisper of a better way to build. If we listen, we might create a legacy as enduring as theirs. The blueprint for the future has always been there, written in stone.